to do here is find these critical z-scores. So those z-star values that are going to show up in calculating your confidence intervals. We're going to look here at 4 key confidence levels. There are 4 of them that show up the most. I'd say especially 95% confidence shows up a lot. And then 99, 90 show up every now and then. Rarely 80% starts dropping a confidence level down quite a bit. Again, if it's like 80% confidence, there's a 20% chance that we're wrong. It's a pretty large percentage chance that we're incorrect. So these are the 4 key values. However, you could see other confidence levels come up. They could ask for like a 92% confidence. What we're going to do here is grab the 4 key ones, but also show you how to calculate it if other levels show up as well. So we're looking at z-scores. So these values are going to come from bell-shaped curve, and the z-scores are going to be landing on our number line. And again, it's the idea that we want to trap that percent confidence in between 2 cutting points. So that's going to be our percent confidence, and then this is going to be our special z-score on this right-hand side. So we want to keep finding this cutoff for each of these different scenarios. It's just this percent's going to be changing. Since we're working with z-scores, we're going to need to use our standard normal curve. So in finding this in the technology I'm using, I have set my mean to 0, standard deviation of 1. So let's go through and find these z-scores. So with 99% confidence, this is going to be the idea that we want 99% of values in the middle here. So we're going to have 99% there, and we want this z-star. What we need, as well as this kind of percentage trapped in the middle, we need to think about what's happening in the tails as well. So if we have 99% in the middle, that's going to be 1% in both tails, but then we need to cut that in half. So where we have this 0.01, we need to divide that in 2, so this would be a 0.005, and so would this over here. So altogether this adds up to 1, where both of the tails should be the same size because of symmetry. So then, using technology to find z-star, using our mean of 0, standard deviation of 1, we want to find the spot that has an area of either 0.995 to the left, or the spot that has 0.005 above. Either way, we'll give you the same value, and rounding to 4 decimal places should get out 2.5758. And this value right here is not going to change. Whenever you're asked for a 99% confidence interval, this is your z-star value. Because with these confidence levels and it being a z-score, this distribution doesn't change based on other information. It stays the same. So what you can do is, if you're using a page of notes for the exams and things like that, you might just want to write down 99% confidence and write down that number right there, because that'll be your go-to z-star value. 95% confidence, which we actually did on the other page, but just to go through the idea again, is to have 95% in the middle, and we want to find this z-star value that cuts right there. We have 95% in the middle, that's going to leave a 0.025 in each of the tails. So using that distribution of the areas, finding that cutoff value, you should get that number of 1.96. Then when we go to 90% confidence, we'll have 90% confidence in the middle, which means we'll have 0.05 in each of the tails, and we want to find that z-star. So using those areas in our standard normal curve should get a z-star value out of 1.6449. And then for 80%, if we have 0.8 in the middle, it's going to leave 0.1 in each of the tails, and finding that cutoff value of our z-star, taking this area to the left of 0.9 or area to the right of 0.1, and that should give a 1.2816. So that's how you can find the critical z-scores, finding the z-star values. And then again, If we keep going to these confidence levels, you don't have to keep recalculating Z-star. It's always going to go back to those. But you'd want to use this method if they gave you something like that 92% confidence level. Then you'll go through these methods of trapping that percentage in the middle, figure out what's in each of the tails, and using technology to find that cutoff value right there.